This video has been sponsored by Odoo. Over the years, I've turned many things into alcohol, like toilet paper and children's glue, and now what I want to do next is turn air into alcohol. This is actually something that I first started thinking about all the way back in 2019 when I realized that air technically contains everything that's needed to make drinkable alcohol. I mean, it of course doesn't have the typical alcohol making ingredients like sugar and yeast, but it does have water vapor as well as CO2 gas, which is theoretically more than enough. This is because together they contain the elements carbon, hydrogen, and oxygen, and with a bit of chemistry, it should be possible to break them apart and to then build them into a molecule of alcohol, or more specifically, ethanol. At the time, I also kind of became obsessed with this idea, and I really wanted to try it myself, and for some reason, I didn't think that it would be too difficult. With just a bit of research, though, I quickly realized that I was completely delusional, and that it would, in fact, be the hardest thing that I'd ever attempted. For example, not only would I apparently have to build an entire gas reactor system from scratch, I would also apparently have to fill it with my own custom-made catalyst and then run it at a legitimately dangerous temperature and pressure, and when I saw this, I kind of just gave up on the idea. However, over the years, as I worked on other projects where I made things like purple gold, superconductors, and even my own liquid nitrogen, I slowly gained more and more experience. Then at some point, I eventually felt that making air alcohol was something that I might actually be able to do, and at the same time, I was really curious to know what it would taste like, and well, I figured there was only one way to find out. With that being said, I then just went ahead and got started, and I felt that the best first step was to put together some sort of plan. So that was what I attempted to do, and after thinking about it for a while, this was what I eventually came up with. To start, I would pull water vapor and CO2 from the air, then I would electrolyze the water to make hydrogen gas, which I could then combine with the CO2 and pass as a mixture over a catalyst, and ideally, this would produce some nice and drinkable ethanol. I mean, this was all, of course, just a very general plan, but it at least gave me an idea of what I was gonna have to do, and I just went ahead and got started by first trying to get the air water and the air CO2. I also felt that the water would be the easiest to get, so that was what I decided to go for first, and I figured that all I had to do was buy a generic home dehumidifier and then run it. So that was exactly what I did, and for the most part, it was as easy as I expected, and I basically just let it sit there, pulling moisture from the air and dumping all of the water into this large beaker. There was one sad and kind of pathetic thing about this whole process, though, which was that I was actually doing all of this in the middle of winter when humidity was already really low. So the process quickly became painfully slow, and it only got slower and slower as it squeezed out the very little water that was even there. This in turn also caused the humidity in my lab to just keep getting lower and lower, and nearly a month later, when I finally had the 1600 mils that I wanted, my lab was so dry that it might have actually been bad for my health. But either way, with all of that thankfully done and over with, I just took all of this nasty air water and I quickly cleaned it up by first pouring all of it into a cheap water boiler. I then added the top part along with a beaker, and after turning on the power, it wasn't long before some nice pure air water started distilling over, and I waited for it all to eventually make it. Then after that, I transferred all of this beautiful air juice to a nice glass bottle, and for the time being, I temporarily put it aside, because what I had to do now was move on to the other main ingredient, which was the CO2. For the CO2, though, I knew that it was going to be a lot more difficult to get than the water, and this was mostly because A, there just isn't that much CO2 in the air to even extract, and B, selectively pulling it out and isolating it is not nearly as straightforward. However, after doing a lot of research into every single CO2 capture method that I was able to find, I eventually came up with a decent plan that I felt would work. I then almost immediately got started with it by first getting my huge container of generic sodium hydroxide drain cleaner and by pouring a bunch of it into a large glass dish. Then, after spreading it out and making it as even as possible, I just let it sit there and I waited for it to start pulling moisture from the air. It also shouldn't have had a problem doing this because sodium hydroxide is extremely hygroscopic, and I was very happy when it only took a couple of days for the entire thing to liquefy into a goopy mess. At this point, though, I should say that waiting for all of the water to come from the air was mostly just out of convenience, and I definitely could have added it myself. But regardless of that, what I had now was an extremely concentrated soup of sodium hydroxide, and at least in theory, it should have been able to do something very important, which was slowly absorb CO2 from the air. What I mean by this is that as it just sat there, CO2 in the air should have been slowly and passively dissolving into the water and then almost immediately reacting with the sodium hydroxide to form sodium carbonate. This in turn should have caused there to be a constant flux of CO2 coming in and getting converted to sodium carbonate, and basically, this liquid should have been able to continually suck CO2 from the air. The very important trick here, though, was that none of this CO2 was truly being destroyed, and it could all be easily released from the sodium carbonate whenever I needed it, and this will all make a lot more sense later on. But with that being said, I then just let it sit there, and I occasionally stirred it, and as more CO2 was captured, more sodium carbonate formed, and it was all supposed to slowly solidify. The only unfortunate part was that just like getting the water, this whole process ended up being excruciatingly slow, and after a couple weeks, I genuinely started worrying that it was never going to be done. However, that thankfully wasn't the case because over the next 2 weeks, it did slowly dry up, and eventually, I was left with some nice and crispy sounding sodium carbonate, which was exactly what I was hoping for. At this point, I was also very relieved to finally be done with this horribly inefficient process, and I was pretty happy with how much I seemed to have made because it was quite a bit, and it was apparently about 2,100 grams. This in turn meant that I'd potentially captured around 850 grams or about 2 pounds of CO2 from the air, which I felt was kind of impressive, and as far as I could tell, this was more than enough for the entire project. But anyway, with all of this powder and air water now in hand, I was ready to move on to the next step, which was to figure out exactly how I was going to be using this stuff to make the ethanol. I mean, I knew that I was going to be electrolyzing the water to make hydrogen gas and using the sodium carbonate to make CO2, and then combining and reacting these gases over a special ethanol making catalyst. But that was just a very simplified plan, and as I mentioned earlier, to actually do this in real life, it would be way more complicated, and it was going to require things like an entire gas reactor system and a very special catalyst. I was also going to have to make all of this myself because both of these things were basically impossible to buy, and they had to be fully custom, and this was quite daunting to say the least. For some reason, though, I still had faith that I could do it, and from what I could tell, it seemed like putting together the reactor system was going to be a little less painful than making the catalyst. So I decided to focus on that first, and I ended up spending the next few weeks just doing research and trying to figure out how high temperature and high pressure reactor systems even worked. Then, when I felt that I had a decent idea, I moved on to the next very important part, which was to put together my own design, and this turned out to be quite difficult for many reasons. However, the main one was that whatever I came up with had to be fully compatible with hydrogen gas, which was not only extremely flammable and potentially explosive, it was also capable of something called embrittlement. What I mean by this is that since hydrogen is such a small element, it's actually able to diffuse into many metals and to slip in between the spaces of their atoms. This in turn can cause the metal to become brittle and to potentially break catastrophically, which is especially dangerous when working at a high temperature and pressure. And the scariest part is that there is technically no way to fully prevent this, but there are some alloys like brass and 316 stainless steel which are much more resistant. So that's what I was going to have to use to build the system, and at the same time, I was going to have to make sure that all of the internal parts of every piece were compatible with hydrogen as well. Also, on top of that, there was one other major thing that I had to consider, which was that this process would produce a decent amount of extremely toxic carbon monoxide, and I would of course have to safely deal with that. With all of this in mind, though, I did eventually put together a design that I felt would work, and I spent the next few months just buying all of the things that I was going to need. For example, I got a bunch of stuff like some gas cylinders and something called a gas booster, as well as some two-stage regulators and a hydrogen generator, and a lot of other random parts and pieces. Then, when I eventually had everything, I started putting it all together, and well, long story short, it turned out that my initial design kind of sucked, and I ended up running into at least a few critical issues. I also ended up spending a ridiculous amount of time dealing with what felt like a never-ending stream of little problems that just kept popping up, and I definitely bought way too many things in my sad struggle to fix them. But I guess this all should have been kind of expected, because I wasn't exactly an expert with any of this, and this was by far the most complicated thing that I had ever attempted. After several painful weeks, though, I finally had something that I was reasonably confident would work, and I went ahead and built an entire wall behind it just to give it a nice white background. Then, with all of that in place, this was the final result, and in my opinion, it was one of the coolest and most impressive things that I had ever built. It was also a lot simpler looking than I ever thought it would be, and this was mostly because I spent a long time trying to make sure that it would be nice and presentable. But either way, overall, I was very happy with how it all turned out, and I was really excited to actually use it, except unfortunately, that wasn't something I'd be able to do for a while. This was because at this point, there was, of course, one extremely important thing that I still had to do, which was to make the special ethanol-producing catalyst and to load it into the reactor over here. So that was, of course, what I was going to have to do next, and I just went ahead and got started with it by first doing a bit more research to try and figure out exactly which catalyst I was going to be making. I then spent a very long time analyzing the ridiculous number of options that I ended up finding, and I attempted to single out what I felt would be the best one, except long story short, it turned out that they were all kind of bad. What I mean by this is that in general, none of them were very efficient, and on top of that, a lot of them had some other major downsides, like being extremely expensive or very difficult to make, or even a combination of the two. This also unfortunately wasn't too surprising, especially considering that even now, the direct conversion of hydrogen and CO2 to ethanol is still a relatively new field of research. That said, I did eventually stumble onto this paper, which I thought looked super promising, because the catalyst that they made seemed to be exactly what I was looking for. And by that, I mean that it was one of the most efficient ones that I was able to find, and on top of that, it was relatively inexpensive. The only slight catch was that it was a two-part catalyst with a so-called CuZnAl portion, as well as an iron-based portion, which meant that it would be a bit more complicated to make. However, after reaching out to the first author of the paper and asking a bunch of questions, I was pretty confident that it wouldn't be too bad. So I kind of just decided to go for it, and at the same time, I figured that the best place to start was with the iron-based portion of the catalyst. This was because, at least based on the procedure in the paper, it seemed like it was going to be the hardest part, and I liked the idea of dealing with it first. And after going over things a few times, I found that there were going to be three major steps. The first was to make something called an iron metal organic framework, or iron MOF for short. The second was to basically burn it and to turn it into something the paper referred to as iron at carbon. And then the third was to coat this with sodium ions to make the final catalyst, called 2% sodium iron at carbon. Overall, I had to admit that altogether this did sound like a lot of work, especially considering that I was going to be massively scaling up the original procedure, but at the same time, I still didn't feel like it would be too bad. So I just went ahead and got started with it by first getting a flask and by adding 300 ml of a solvent called dimethylformamide, or DMF for short. Then into this, I quickly added 3.6 grams of iron chloride tetrahydrate, which almost immediately started dissolving and forming some nice colored complexes with the DMF, and after letting it sit there for a bit, I turned on the stirring. This caused the solution to quickly become an even darker orange and for it to slowly get darker and darker, and once it had completely dissolved, I quickly added the next ingredient, which was something called triethylene diamine, also known as DABCO. Like the iron chloride, this caused a nice and strong color change, and what should have been happening here was a reaction between the DMF iron chloride complexes that I just made and the DABCO. As far as I know, this was leading to the formation of a bunch of different intermediates, where the major one was probably some so-called hydroxo iron species. It was going to take at least a few minutes for it to all react though, so in the meantime, I went and got my addition funnel, and I added it to the top of the flask. With that in place, I was then able to add a nice and clear solution that I'd made by dissolving a small amount of terephthalic acid in about 70 ml of DMF, and when I was done with that, I looked back at the reaction, and it seemed good to go, so I carefully opened the funnel. This caused the solution to be let out really slowly, and my goal was to add it all dropwise, and this time, there wasn't an immediate color change or anything. In theory, though, the terephthalic acid was supposed to be reacting with my mixture of random intermediates and leading to the formation of a new complex that's generally referred to as an Fe3O trimer. However, these trimers wouldn't stay on their own for very long because they were all supposed to continue reacting with the terephthalic acid to form intermediate molecules that could then combine with each other. This in turn was supposed to lead to the formation of a massive and highly ordered structure that would be held together by strong bonds between the iron and terephthalic acid, and in general, this is known as a metal organic framework, or MOF for short. But anyway, once it was all added, I transferred it all to a Teflon container, and after sealing it, I dropped the entire thing into a large stainless steel pressure chamber. This was because most of the reaction that I just mentioned wasn't really going to be able to happen at room temperature, and in order to actually make them off and to have it form with the proper crystalline structure, I was going to have to heat it up under pressure. So that was exactly what I did by just putting the entire thing in my oven that I had preheated to 120°C, and after leaving it there for about 24 hours, I took it all apart and I pulled out the Teflon container. I then quickly popped it open, and the first thing that I noticed was that the color was way brighter than before. And in my opinion, it kind of just looked like some generic paint. But as far as I could tell, this was exactly what I was looking for, and what I had now should have been just a bunch of MOF floating around in a soup of DMF, along with a bunch of other random side products. I, of course, only wanted the MOF though, and the rest of the stuff was just trash, so what I was gonna have to do next was purify it out, and I was honestly a bit worried that this was gonna be a huge pain. But despite that, I just went ahead and got started, and well, for the most part, it actually ended up being relatively simple. And by that, I mean that basically all I ended up doing was just centrifuging it to push all of the MOF to the bottom of the container, which allowed me to easily get rid of the dirty DMF. Then after that, I was able to clean it up even more by washing it with some fresh DMF and by using the centrifuge again to knock everything to the bottom. I also ended up repeating this cycle a few more times just to really make sure that it was all clean, and when I was eventually done with that, I put it all into my vacuum oven. This was because I wanted to get rid of any remaining DMF and to dry it as much as possible, and a few days later, this was what I was eventually left with. Just a nice pile of dry and crunchy powder, which should have been nearly pure, iron-based MOF, and with this now in hand, I was feeling pretty good. At this point, I was also officially done step 1 of this catalyst, and I could now move on to step 2, which was to basically burn everything that I had just made and to turn it into iron at carbon. So that was what I immediately started working on next, and the first thing that I did was quickly put together this little setup, where over here I had a high purity nitrogen tank that would allow me to flow nitrogen gas out of this black tube and into this flow meter, and then into this tube furnace. At the same time, I also had this vacuum pump that was connected to the same end of the tube furnace, and this will all hopefully make a lot more sense in a few minutes. But with that being said, I then just got started with things by first transferring all of my powder to an alumina boat. I then slid it into the quartz tube that was sitting inside the tube furnace, and after loading in another alumina plug and sealing the open end, I flipped on my vacuum pump. This caused all of the air in the tube to get sucked out, and once I saw that I had a nice stable vacuum, I closed the valve to the pump, and I refilled the tube with some high purity nitrogen gas. Then, after repeating this process 2 more times, just to make sure that there was only nitrogen in there and effectively no oxygen, I opened the valve on the end of the tube so that nitrogen could flow through it, and I carefully adjusted the flow rate to 500 mils a minute. With all of that done though, it basically should have been good to go, and at this point, I was feeling pretty good about things. So I just went ahead and flipped on the heating to start the whole cooking process, and the goal now was to slowly raise the temperature at a nice and steady rate of only 2 degrees per minute. It was also going to have to go all the way up to 550 C, which meant that this was going to take a while, and for the first couple of hours, not too much happened. However, when it eventually got to around 200 C, I started to see some smoke coming out with the nitrogen, and as it continued getting hotter and hotter, it slowly got smokier and smokier. Then, by the time that it got to 450 C, it was just blasting out, which I thought was pretty satisfying to see, and as far as I could tell, this was exactly what I wanted. It also told me that everything that I'd put in the tube was definitely breaking down, which was good, except I should probably say that all of this stuff blasting out technically wasn't smoke, and that nothing in there was actually burning. This was because with no oxygen present, it would be impossible to burn, and instead, it all should have been gently breaking down through a process called pyrolysis. More specifically, the MOF should have been slowly decomposing and turning into gases like carbon monoxide, hydrogen, methane, and CO2, which was all getting carried out of the tube by the nitrogen. Left behind, though, would hopefully be a bunch of carbon in the form of charcoal, which is basically the stuff that's found at the bottom of a fire, and this probably doesn't sound too special. But in this case, it would be, because it would all be coming from the iron-based moth, which has a unique and highly ordered structure with a very specific arrangement of iron atoms. This in turn was supposed to result in a highly porous charcoal that was filled with an extremely even dispersion of iron-based nanoparticles, and this was what the paper referred to as iron at carbon. But anyway, as it continued getting hotter, the amount of smoke gradually got less and less, and by the time that it got to my target temperature of 550 C, there was barely any coming out. Then, as I continued heating it, the smoke only continued to decrease, until a few hours later, when it eventually stopped coming out at all, and at this point, everything in there should have been fully degraded. So what I did next was just turn off the heating, and I waited for the entire oven to cool down, and when it eventually got to a reasonably low temperature, I just went ahead and opened it up. What I then saw was that everything had become completely black, which was exactly what I wanted, and it was definitely very different than the nice salmon-colored stuff that I'd put in. As far as I could tell, it also looked like it had been fully carbonized, meaning that what I had now should have been just a bunch of carbon filled with a fine dispersion of iron nanoparticles, and overall, I was pretty happy with how it all turned out. The only slightly concerning part was that upon closer inspection, I did notice that there was actually some red color in a few places, which at first, I thought might have been some stuff that didn't break down. Then on top of that, I also noticed that everything that I had was actually brown and not black, like pure carbon should have been. However, after looking back at the paper, I quickly realized that this made a lot of sense, because it clearly stated that a lot of the iron was supposed to be turning into iron 2 oxide, which is brown. Also, for the small amount of red stuff, I came to the conclusion that it was likely just due to a bit of oxygen contamination, and as far as I could tell, it was all just superficial, and it wasn't going to be an issue. But regardless of that, at this point, step 2 was now done, and with only one step left, I was already getting really close to having my finished iron-based catalyst, and so far, I had basically run into no real problems. I mean, that was until I weighed it, and I saw that what I had made was only 1.8 grams, which was way less than I ever imagined I would get from this, especially because I had already scaled up this reaction by 6 times. The final step wasn't going to add any real mass to this either, which meant that 1.8 grams was the max that I was going to get, and this was more than just a little concerning. This was because, based on my calculations, I was going to need at least 25 grams of it to make ethanol at a decent rate, and to get that, I would apparently have to repeat the entire process 13 more times. And considering that what I had just done had taken about 5 days, I was potentially looking at up to 65 days of work. Just thinking about that kind of hurt my head though, and at this point, I was extremely tempted to just quit on this catalyst. However, at the same time, I still felt that there was some hope, and after thinking about it for a bit, I was pretty convinced that all I had to do to get through this was just scale things up even more. From what I could tell, there was also only one major bottleneck that was stopping me from doing this, which was the stainless steel pressure chamber, and it seemed like all I had to do was buy a massive one. So I just hopped onto Alibaba, and after searching around for a bit, I ended up buying this one, which was the biggest one that I could get before the price skyrocketed and became completely unreasonable. Then, when it eventually arrived a few weeks later, I just jumped right back into things by basically doing the exact same process all over again, except on a much bigger scale. At the beginning, everything also seemed to go totally fine, and with step 1, the only issues that I ran into were some slightly annoying things. Like the fact that the new reactor was way heavier than the other one, and once it was loaded up with the entire reaction mixture, it weighed around 80 pounds. This made it a pretty painful process to get it both in and out of the oven and to move it around in general, and I even had to reinforce the rails in the oven to prevent them from breaking. On top of that, having to deal with so much more product made the centrifuging and cleaning steps a lot more tedious, and I ended up having to get my rotovap going just to deal with all of the extra solvent. However, all of that turned out to be very pleasant compared to what came next, with step 2, when I realized that I'd somehow completely forgotten that I could only load one boat at a time into my tube furnace. This meant that the whole process still had one major bottleneck, and I have no idea how this completely slipped my mind. Regardless of that, though, I ended up deciding to just power through it instead of trying to buy a bigger tube furnace or something, and let's just say that it was pretty painful. This was because, with one boat at a time, I ended up having to repeat the process 14 times, and considering that each run took a full day, this was basically all I did for 2 weeks. What also made things extra fun was that at the same time, I had to keep repeating step 1 so that I would have moths ready to continually load into the oven, and pretty much the entire time that I was doing this, I was kind of wishing that I had just given up. But either way, in the end, when I did eventually finish, the final result was 4 separate jars with about 6 grams of iron at carbon in each one, and at this point, I was honestly so beyond done with this process. However, on the bright side, in total, I somehow ended up with exactly 25 grams, which was suspiciously convenient, and now, with step 2 officially completed, I was super close to finally being done with this catalyst. As far as I could tell, it also seemed like the last step was actually going to be really easy, because I just had to add some sodium ions to what I already had, and according to the paper, all I had to do was a process called Wetness impregnation. The only slightly tricky part was that I'd honestly never heard of that before, and when I Googled it, I was only able to find very general information about it, but not exactly how to do it. After looking around forever though, and watching every random video that I could find, I eventually felt that I knew how to do it myself. So I just went ahead and got started by getting that first small batch that I'd made, and by dumping it all into a bowl. And on top of this, I quickly added all of the stuff that I had in the jars, which altogether now gave me a total of 26.8 grams, and after stirring it around a lot to make sure that it was fully mixed, I transferred a small amount of it to a dish. I then very slowly and dropwise started adding a solution of ethanol in water, and the goal here was pretty simple. All I had to do was carefully add the solution with a lot of mixing in between the additions, and to go just until the point that it started clumping. Because at this point, it would mean that the powder was at its limit of what it could absorb, and when I eventually saw this happening, I wrote down exactly how much liquid was used. Then after that, I repeated this 2 more times, with each run giving me a ratio of liquid to powder, and after averaging things, I found that the ideal quantity was 1 milliliter of liquid to 0.293 grams of the catalyst. With this in mind, I was also able to calculate that I would need exactly 87 milliliters of the ethanol solution to perfectly coat all of the catalyst that was still in the bowl, and I added that amount to the beaker. Then into this, I added 1.16 grams of sodium carbonate, which would serve as my source of sodium ions, and once it all eventually dissolved, I went back over to the powder, and I quickly ground it to a dust. I then started to dropwise add the solution that I had just made, with a lot of stirring in between, and the goal now was to basically add everything, and to coat the catalyst as evenly as possible. The key here, though, was that in doing so, all of the sodium carbonate that I had added would get perfectly distributed throughout the powder. I'd also specifically used 1.16 grams of the sodium carbonate because I calculated that this was exactly how much I would need to get a final catalyst that was 2% sodium by weight, which, according to the paper, was the ideal amount. But anyway, when I was eventually done, it was looking a bit more wet than I would have liked, except I felt that this was fine, and I quickly dried it by putting it in my vacuum oven. Then, when I took it out a few days later, what I had was a super nice and dark powder, which in theory was the 2% sodium iron carbon catalyst that I was hoping for, and now, after working on it for nearly 4 months, I was finally done. At this point, I was also so beyond tired of this catalyst, and this project in general, that I ended up working on some other stuff for a week, just to clear my mind. After that, though, I felt that I was ready to jump back into things and to make the second catalyst, which at least initially seemed like it was going to be roughly 1,000 times easier. Because as far as I could tell, the whole process was somewhat similar, except way more straightforward, and the basic idea was to first make the so-called CuZnAl precursor, then roast it to make the proper CuZnAl catalyst, and then after that, add some potassium ions to make the final 5% potassium CuZnA. The only slightly tricky part was that for some reason, the procedure in the paper was missing some fundamental key details like concentrations and amounts, which definitely wasn't ideal. However, after doing a lot of research and after reading every single similar procedure that I could find, I was eventually able to come up with my own numbers, and I was at least pretty sure they would work. So, with these numbers in mind, I just went ahead and got started by first adding a bit over half a liter of distilled water to a large beaker, followed by 71.04 grams of copper nitrate. This almost immediately caused a lot of the water to turn a really nice blue color, and I quickly followed this up with 35.1 grams of zinc nitrate and 22.06 grams of aluminum nitrate. With all of these nitrate salts added, I then turned on the stirring to help dissolve everything, and when it all eventually disappeared, I dumped in the last ingredient, which was urea, and I added 180.18 grams. Just like all of the other stuff that I had added, this also dissolved relatively quickly, and when it was all eventually gone, I poured in some more water to bring it up to 2 liters. This then finally left me with a nice blue solution that contained a very specific concentration of urea and nitrate ions, and where the ratio of copper to zinc to aluminum was 5 to 2 to 1, and apparently, all of this was super important for how the final catalyst would turn out. I should say, though, that up until now, no reaction had happened yet, and to actually get things going, I was gonna have to heat it up. So that's what I did next by turning on the hot plate, and at the same time, I carefully watched it as the temperature slowly rose, and when it eventually got up to around 60 C, it didn't look like there was much of a difference. However, at least in theory, the urea should have been starting to break down into ammonia and CO2 gas, with the ammonia causing the solution to slowly get more and more basic. Then, as the solution continued heating up, the rate of urea breakdown was supposed to increase as well, and at least based on the amount of bubbling that I saw, that definitely seemed to be happening. What I thought was much more interesting, though, was that when it eventually got to 95 C, the solution started becoming cloudy, and this was because it was at this point that the catalyst was starting to form. More specifically, the metal nitrates that I'd added were now starting to be affected by the pH, which was causing them to slowly turn into various hydroxides and hydroxycarbonates that were no longer soluble in the water. This in turn was causing them to slowly precipitate together as a very intimate mixture of copper, zinc, and aluminum, and with a very specific ratio of 5 to 2 to 1, and at least so far, everything seemed to be going exactly as planned. But anyway, at this point, I basically just had to keep heating it like this for a couple of hours, which should have been enough time for pretty much all of the metals to get knocked out. During this time, the color also seemed to change quite a bit, which I assumed was good, and when it was eventually done, 2 hours later, I was pretty happy with how things were going. With the main reaction now done, though, what I had to do next, according to the paper, was age it for 24 hours, and in my experience, this usually meant to just leave it how it was. However, at least based on what I'd seen in other similar procedures, that wasn't always the case, and what really didn't help was that there was absolutely no further information about any of this anywhere in the paper. So I kind of just ended up doing what I felt would work, and by that, I mean that I decided to leave it stirring, but to knock the temperature down to 65°C. I then just let it sit there, and over the next several hours, all I did was occasionally add water to it, and for the most part, it seemed like things were going okay, except for some reason, I just couldn't shake the feeling that I was doing something wrong. So, out of pure anxiety, I ended up reluctantly emailing the author again, which I really didn't want to do, because I had already pestered him with way too many questions. However, I'm glad that I did, because it turned out that everything that I was doing was totally wrong, and he basically told me to do the complete opposite. More specifically, I was apparently supposed to keep it at the same temperature of around 95°C, and I was supposed to completely stop the stirring, which he said was important for catalyst particle size. So apparently, everything that I decided to do was wrong, and now everything that I had in this beaker was just a bunch of trash, and this was pretty disappointing. But that's just kind of how it goes with chemistry sometimes, and what I did next was the only thing that I could do, which was just restart by first getting rid of this entire reaction. Then after that, I basically redid everything that I'd just done, except this time, after heating it for the 2 hours, I transferred the entire thing to my sous vide, which was normally meant to cook things like steaks. In this case, though, I felt that it was perfect for what I had to do, and it should have had no problem holding the reaction at a near perfect 95°C. On top of that, with the lid, it also should have been able to drop the water loss to almost zero, and this was amazing because it meant that I wouldn't have to constantly come back to add extra water. But with that being said, all I had to do now was basically wait, and when I came back to it 24 hours later, it at least seemed like the aging process had made a difference. I mean, all of the solid stuff definitely looked different, and the solution was a darker blue color, and as far as I could tell, this was exactly what I was hoping for. At this point, I was also officially done aging it, so what I did next was quickly pull the beaker out of the sous vide. I then started pouring it all into a vacuum filter, and I was doing this to separate out all of the solid stuff and to get rid of the nice blue liquid, which was unfortunately just trash. When it was all eventually gone, though, all that I was left with was a little green puck that should have been my crude catalyst precursor. However, right now it was still a bit dirty, and I was going to have to clean it up, so I did that by washing it a few times with distilled water, and after that, I transferred it to a vacuum chamber. Then, as it sat there, it slowly dried up, and when I eventually took it out a few days later, this was what I was left with, which was a beautiful chunk of nice and crunchy powder. At this point, I was also officially done step 1, which I was really happy about, and so far, despite having to completely restart, this process was already way easier than the other one. With that being said, though, what I had to do next was move on to step 2, which, as I mentioned earlier, was a roasting step, and I was a bit worried that it would end up being just as painful as the pyrolysis one. However, long story short, that was not at all the case, and it was probably the easiest thing that I had to do for this entire project. because unlike with the pyrolysis, I was able to do it with air present, and I didn't need any specialized stuff like a tube furnace or nitrogen gas. All I had to do was load it into this little tabletop furnace and to slowly heat it to 350 C, and during this time, all of the powder would slowly decompose. More specifically, all of the metal hydroxides and hydroxycarbonates would slowly break down, releasing water and CO2 gas, and leaving behind a mixture of copper oxide, zinc oxide, and aluminum oxide, which was my proper CuZnAl catalyst. This also caused the powder to turn completely black, which was exactly what I wanted, and after leaving it overnight to cool down, this was what I was left with. Nearly 36 grams of hopefully decent CuZnAl catalyst that at least looked like it had been roasted nice and evenly, and overall, I was very happy with how it had turned out. At this point though, there was of course one last thing that I still had to do, which was to convert it to the 5% potassium CuZnAl, and again, this was thankfully super easy and straightforward. This was mostly because after learning from the last one, I already knew exactly how to do it, and I started by testing how much water the powder could absorb. Then after that, I quickly put together the coating solution, except this time I just used pure water and not a solution of water and ethanol, and I used potassium nitrate instead of sodium carbonate. I also used 4.48 grams of the potassium nitrate so that the loading would be exactly 5%, and once I had added all of the solution to the catalyst, I dried it in my vacuum oven. Then, a few days later, I took it out, and what I had now was about 35 grams of super nice and dry powder that should have been my final 5% potassium CuZnAl, and at this point, I was feeling pretty good about how everything was going. At the same time, I also couldn't believe just how much easier and faster this one had been, especially considering that from start to finish, including the screw-up, it had barely been a week. But moving on, with both of the catalysts now finally done, the only thing left to do was to mix them together and to load them into the reactor. So that was immediately what I started working on next, and the first thing that I did was use some sieves and a hydraulic press to get them to a very specific and uniform grain size of 20 to 40 mesh. Then after that, I quickly added 25 grams of the CuZnAl, followed by all of the iron catalyst that I had made, to a glass jar. At the bottom, there was also already a small amount of inert quartz sand that I'd added beforehand, and this was because according to the paper, including some sand was supposed to make the final catalyst slightly more efficient. But with that being said, once everything was loaded in, I shook it around to mix it up as much as possible, and when I eventually felt that it was looking good, I went over to the main setup and I got the reactor. Then, after bringing it over to my vise and clamping it in upside down, what I did next was carefully add all of my newly mixed catalyst. I also tapped it a bunch of times with a hammer to help pack it down as much as possible, and after topping it off with a bit more quartz sand, I added some special goo to the threads along with a puff of quartz wool, and I sealed it with an end cap. At this point, the reactor was effectively ready, so I quickly tested it by passing some high-pressure CO2 through it, and once I saw that it looked good, I blasted it with a heat gun to cure the sealant. Then after that, I reattached it to the main setup by reconnecting the compression fittings and by clamping the reactor to the stand. While I was at it, I also rewrapped it with the custom heating jacket that I had ordered from Alibaba, which would allow me to precisely heat the tube all the way up to 600 C, and with all of this in place, I was feeling pretty excited. This was because after nearly 2 years of tedious work, the full setup with the catalyst was finally done, and at least in theory, I was now very close to achieving my dream of air alcohol. At the same time, though, I was feeling a bit nervous because I still had no idea if any of this would actually work, and it was very possible that it would all just end up being a bunch of useless junk. Or worse, it could end up catastrophically exploding or something, but I figured there was only going to be one way to find out, and I was going to have to actually try running it. So that's what I immediately started working on next, where the first step was to load up the system with all of the air water and air CO2 that I'd collected years ago. And at least for the water, this was going to be extremely simple, and I basically just had to pour it all into my hydrogen generator. For the CO2, though, it was going to be a bit more complicated because it was all still trapped in this crunchy sodium carbonate, and to use it, I was first going to have to release it, and then I was going to have to somehow recapture it, and then I was going to have to store it as a pure high-pressure gas. However, I felt that I had a relatively simple way of doing this, and I just went ahead and got started with it by transferring about half of it to a huge round-bottom flask, followed by a whole bunch of distilled water. Then after that, I quickly put together this somewhat complicated-looking setup with this huge funnel over here that was filled with a bunch of acid, and when I opened the valve, it all started flowing into the flask. This then immediately caused there to be a bunch of bubbling, and this was because it was reacting with the sodium carbonate solution and releasing some of the CO2 that I had trapped years ago. As it was made, all of this CO2 was also leaving the flask, and it was getting dried as it passed through the condenser and through the calcium chloride. The key here, though, was that pure and dry CO2 was then eventually making it to this chamber here, and after running the system for a few minutes, I added a whole bunch of my own homemade liquid nitrogen. This caused the chamber to quickly cool down to the point that it could start freezing the CO2 gas on the walls of it, and the idea here was to trap it in its pure solid form, which is commonly referred to as dry ice. At this point, I also didn't have to do very much besides occasionally adding more acid to the funnel and more liquid nitrogen to the bowl, and patiently waiting for all of the sodium carbonate to disappear. So in the meantime, I went and got my pressure chamber from the main setup that was originally built for my aerogel project years ago, and I clamped it upside down in my vise. While I was at it, I also added a funnel and a camera, as well as an argon line, and after that, I just went back to waiting for it all to react. It was then a few hours later when all of the sodium carbonate was finally gone, and what I did next was pull the chamber out of the liquid nitrogen. I then opened it up, and I quickly started breaking apart all of the dry ice, which was honestly a surprising amount, and when it eventually looked like it was just a bunch of snow, I felt that it was good to go. So I went over to the pressure chamber, and after flushing it with a bunch of argon, I started loading it in as fast as I could, because I wanted to lose as little dry ice as possible. Then, about 30 seconds later, when it was all in the chamber, I quickly sealed it by adding a small plug, and after that, I immediately looked over at the pressure gauge, which was now starting to rise. And when it eventually got above 100 psi, all of the dry ice suddenly started to melt, because at this pressure and at room temperature, it instead wanted to exist as a liquid, and I thought it was really satisfying to see it all slowly liquefy. With all of that done, though, I now had a chamber that was filled with about 250 grams of CO2, which should have been more than enough, and I reattached the whole thing back to the main setup. With it securely in place, the full system was then fully ready to go, and at least theoretically, there was very little stopping me from just going ahead and running it. I mean, besides the fact that it was already 3 a.m. and I was absolutely exhausted because this entire CO2 part had taken way longer than I had ever expected. When I came back to it the next morning, though, I pretty much immediately got started by first opening up the CO2 chamber and by adjusting the pressure regulator, and as I did this, CO2 started flowing out the back of it. It was then getting pushed up the copper tube and through this much bigger tube, which was removing any potential contaminants like moisture, oxygen, and hydrocarbons, and once it got to the end of it, it was supposed to be extremely pure. But with that being said, with the CO2 now up to this part here, I quickly opened this needle valve as well as this bleed valve, and I let the CO2 flow through this part of the system until I was sure that I had pushed out all of the air. Then after that, I moved on to flushing the air out of the rest of the system, which was relatively easy, and all I had to do was use these 4 valves here and to alternate them back and forth. This was because each of them was equipped with a vacuum line as well as an argon line, and by repeatedly going between vacuum and argon on each section, I was able to completely flush out the air and replace it with a slight pressure of inert argon. With the system fully air-free, I was then able to safely flip on my hydrogen generator, which almost immediately started electrolyzing the air water and splitting it into hydrogen and oxygen. However, all of the oxygen was just being thrown away, and only the hydrogen was being kept, and when the pressure of the hydrogen eventually got up to 1 megapascal, or 145 psi, I opened this special valve on the reactor side of the setup. This allowed pure hydrogen gas to start traveling down a tiny tube hidden in the back and through the reactor, and I adjusted the flow rate by opening this valve here and by carefully turning a knob on the hydrogen generator. Then, when I eventually got the reading on the generator to 300 mils a minute, which was the max amount of hydrogen that the machine could safely make, I turned on the heating jacket. I also started cranking up the temperature, and this was because what I had to do now was activate the catalyst and to turn it into a form that would be able to make ethanol. So that was exactly what I did, and when the temperature eventually got to around 330 C, I noticed that some small drops of water were starting to fall into the flask. Then, by the time that it made it to 400 C, I saw that a little puddle had formed, which I thought was good, and I felt that this was strong evidence that the catalyst was actually getting activated. This was because water was a direct product of the activation, and it was forming as the hydrogen reacted with the catalyst. More specifically, it was reacting with the oxygen in the catalyst, and in the case of the potassium CuZnAl, it was supposed to be attacking the copper oxide and reducing it to copper metal. This metal was then supposed to just sit there, all bundled up with the zinc oxide and aluminum oxide, which weren't going to be affected by the hydrogen. In the case of the sodium iron at carbon, though, the hydrogen should have been reacting with all of the iron oxide and reducing it towards metallic iron. And I say towards because this iron metal would never really exist, and it was supposed to be almost instantly picked up by the carbon that was surrounding it and turning into iron carbide. Both of these together would then make the so-called activated form of the catalyst, and at least in theory, they were supposed to be able to work together to make ethanol. But anyway, after cooking it for 2 hours, it should have been fully activated, and what I did next was close the hydrogen valve, and I replaced it with a very slow flow of argon. Then right after that, I started lowering the temperature of the heating jacket, and my goal was to eventually get the reactor down to 320 C, which was the optimal temperature for the ethanol reaction. However, I knew that this was going to take a bit of time, so while I was waiting, I decided to go over to the other end of the setup and to start preparing the hydrogen and CO2 gas mixture. This was also, thankfully, going to be relatively easy, and the first thing that I did was just open this valve here, which caused hydrogen to rush in and to spike the pressure in this section to 145 psi. I then used the regulator to knock it down to the same pressure as the CO2, and with the bleed valve open, I used this needle valve to increase the flow of hydrogen, and again, I adjusted it until I got 300 mils a minute. At the same time, I also looked at the ball in the flow meter to make sure that it was indicating the same flow rate, and when I confirmed that it was, I opened up the CO2 valve. This caused the CO2 to rush in and to mix with the hydrogen gas, and what I did next was try to adjust the flow of CO2 until the ball got to just above the 45 marking. Because at that point, the flow of the CO2 would be about 100 mils a minute, which would be 1/3 that of hydrogen, and according to the paper, that was the ideal ratio. But either way, when it eventually got there, my low pressure gas mixture should have been good to go, so I closed the bleed valve and I opened the valve below it. This then allowed it to flow into the next part here that was filled with some silica beads, except in hindsight, I honestly think it was kind of pointless, and what was much more important was that it eventually made it to this section here, and that it started filling the small gas cylinder. This was because now I was actually starting to collect my gas mixture, and I was making a very important little buffer that the gas booster could pull from, and when it eventually got to around 80 psi, I opened this valve. This then allowed the gas to rush into the booster, and at first, nothing happened, until I started turning the valve on the left, which caused the whole thing to come to life. And by that, I mean that it immediately started compressing my gas mixture, and with every cycle of the system, the pressure of it slowly increased. I should also say that this entire thing didn't need any electricity to do this, and it was working entirely on compressed air that was being fed in through the blue tube. But with that being said, when I eventually saw that it had been boosted all the way up to 800 psi, I opened this valve here to release this new high-pressure gas mixture into the next part. Then, after waiting a couple minutes for the pressure in the system to stabilize, I immediately started adjusting this regulator. I also did my best to set it so that the gas coming out would get knocked down to about 725 psi, and once I had done that, I was feeling pretty excited because now, my high-pressure mixture of hydrogen and CO2 was officially ready to go. So what I did next was check out the temperature of my reactor, and when I saw that it was already sitting nicely at around 320 C, all of my excitement almost immediately shifted to nervousness. This was because at this point, everything was good to go, and finally, after way too much effort, it was time to see if it would all actually work to make ethanol, and apparently all I had to do was open this valve.
Okay. Good luck me, I guess.
So that was exactly what I did, and this almost immediately caused the high-pressure gas to rush into this last section and into the reactor, and when I looked at the pressure gauge, I was happy to see that it was increasing. I was also very happy to see that, so far, nothing had exploded, and that there weren't any jets of fire shooting out, and with it seemingly safe, I carefully adjusted the flow rate a bit using this valve here. Then after that, I felt that for the most part, everything was looking pretty good, and now, at least in theory, as the hydrogen and CO2 passed over the hot catalyst, it should have been turning into some amazing ethanol. How this was hopefully happening was also apparently quite complicated, and the paper actually suggested 4 different pathways that were probably occurring all at the same time. However, the main idea behind all of them was kind of similar, and they all started with hydrogen and CO2 getting picked up by the potassium CuZnAl. And while they were there, on the surface of the catalyst, they would react together, which would turn the relatively inert CO2 into something that was much more reactive, like carbon monoxide or formate. These intermediates would then be able to diffuse away, but they wouldn't make it far, and they would almost immediately come into contact with the iron-based catalyst. This would then use some more hydrogen to turn the carbon monoxide into a small hydrocarbon fragment, and after that, it would link this fragment to one of the reactive intermediates that was just made by the potassium CuZa. This would lead to the formation of a new aldehyde intermediate, which would then quickly react with even more hydrogen to produce the final ethanol. And all of this was, of course, happening at 320 C, so any ethanol that was made would be in its gas form, which would then get pushed out of the reactor and into the cold condenser, where it would hopefully liquefy before dripping into the flask. Also, one thing that I should mention is that this reaction isn't super efficient, and only about 35% of the CO2 that reacts is supposed to turn into ethanol, and a lot of it would be turning into other hydrocarbon side products. On top of that, a lot of unreacted hydrogen, CO2, and carbon monoxide would for sure be coming out the end of the system, which was why it was very important to feed everything through this tube in the back and into my fume hood. But with all that said, by now, the system had been running for at least several minutes, and at this point, I was starting to feel pretty good about how things were going. I mean, that wasn't until I realized that the reactor was failing to achieve the proper pressure of 725 psi, and that I wasn't going to be able to do anything about this. This was because there was apparently something wrong with the needle valve that was making it impossible to reduce the gas flow any more than what it was, and this meant that it was going to have to stay at around 600 psi, which wasn't exactly ideal for this reaction. However, as far as I knew, it still should have been able to make ethanol, and it would just be a little less efficient, and I figured that my only real option was to just keep going with it, and to hope for the best.
Gotta give it a chance.
So, that's what I did, and at some point, I decided to freeze the receiving flask with a bunch of liquid nitrogen just to be absolutely sure that I captured everything that came over. This also caused the entire flask to slowly turn white, which confirmed that I was for sure collecting something, and I was really hoping that this was mostly my amazing ethanol. But anyway, as it sat there, I slowly got more and more excited as I saw it gradually build up, and after patiently waiting about an hour, I had collected what looked like a decent amount. So I just decided to shut it down, especially because it was already 4 a.m. and I was absolutely exhausted, and I did this by closing the main gas valve and by switching it over to a flow of argon. Then after that, I took away the liquid nitrogen and I started warming it up with a heat gun, and as I was doing this, I was just hoping that it would all magically melt and form a huge pool of ethanol. However, almost immediately, I started getting really concerned when I saw that a lot of it was just vanishing, which meant that unfortunately, most of it was probably just unreacted CO2. Then, as I kept heating it, my concern only got worse and worse as it continued disappearing, and what was really sad was that by the time pretty much all of it had melted, there was basically nothing left. I mean, there was definitely a small puddle there, but it looked like it was at most maybe a few milliliters, and I was pretty sure that this was all just the water that was left over from the catalyst activation. This was also very bad, to say the least, because this basically meant that the catalyst had not worked properly, or more likely, even at all, and at this point, I was not exactly having good and positive thoughts about things.
Yeah, so that's it. It's a total failure. I have officially given up all hope, and I believe the catalyst is crap. So yeah, I officially give up.
But that all quickly changed when I came back to it only several minutes later, and I noticed that there was somehow way more liquid, and that there were drops continually coming over, and I had no idea why this was happening.
That makes no sense. There's now a steady drip rate. under argon. I'm struggling to understand what's happening. What? What is that that's coming over?
At the same time, I also started thinking that some of this could be my ethanol and that somehow it had just gotten trapped in the reactor or something, and I actually started to get some hope that it wasn't just a complete failure. So, what I did next was quickly take the flask off the setup, and after swirling it around to mix it all up, I transferred a small amount of it to a glass tube. I then carefully loaded this tube into my little NMR, and after patiently waiting a couple of minutes, this was what it eventually showed me. And at first, I was kind of sad because right away I saw this massive peak here, which told me that it was basically just water. However, when I looked a bit closer, I noticed that there were some small peaks down here, and after stretching it out a lot and labeling them, I was actually pretty happy with what I saw.
That is actually pretty exciting. Wow.
Because what I saw was that without a doubt, there was some ethanol in there, which meant that the catalyst had in fact worked to some degree.
It worked?
This also meant that at least technically, I had succeeded at turning air into alcohol, and at this moment, I was feeling pretty excited.
It made a detectable amount of ethanol. It's working. Maybe. It's maybe working.
At the same time, though, it was hard to feel too excited or celebrate it because what I had made was still nearly pure water with an almost undetectable amount of alcohol in it. And what also really didn't help was that, unfortunately, I wasn't even sure what had gone wrong. But after thinking about it for a while, and after doing a bunch of research, I was eventually pretty sure that the main issue was that I just completely failed to properly activate the catalyst. On top of that, I had only run it at 600 psi instead of the ideal 725, which just made everything even worse by making a barely functional catalyst even less efficient. On the bright side, though, the fix for all of this seemed relatively simple, and for the most part, I figured that all I had to do was replace my little hydrogen generator with one that could output a lot more hydrogen. So that was exactly what I ended up doing, and while I was at it, I decided to do a few more fixes and upgrades, like swapping out the valve at the end for one that would actually seal, and changing out the flow meter and the bubbler for ones that could handle much more gas. I also spent a few days collecting a lot more water, which would be needed for this huge hydrogen generator, and this time it was way easier because it wasn't winter and there was plenty of humidity in the air. But either way, with all of that done, the new setup was basically ready to go, and I was feeling pretty hopeful that this time it would actually work. So I basically just cleared my schedule and I jumped right into it by first generating some more CO2 with the last bit of sodium carbonate that I had, and by transferring it all to my aerogel chamber. I then reconnected it back to the system, and after flushing the air out of the entire thing, I turned on my brand new hydrogen generator. Then after that, the first thing that I did was reactivate the catalyst, which as I mentioned before, likely didn't get fully activated the first time, and I felt this was mostly because of the really low flow of hydrogen. What also made this problem even worse was that for some reason, I had only run the activation for 2 hours when it should have been done for closer to 8, and overall, I think I had just completely screwed up. But with all that being said, I then waited for the catalyst to hopefully activate, and over the next several hours, I ended up collecting way more water than I did before, which I felt was a really good sign. And when it eventually got to the 8-hour mark, the catalyst should have been good to go, so I dropped the temperature to 320 C, and I quickly prepared the gas mixture. Then, when I felt that I was ready, I unleashed it, and I was very happy to see that with my new valve and with the significantly bigger hydrogen generator, I was easily able to keep the pressure at around 725 psi. I was also very happy to see that this time there was a lot more gas passing through the bubbler, because this meant that more gas was passing over the catalyst, which in turn meant that it could be making ethanol more quickly. At the same time, though, I still had no idea if it was actually working, and even after letting it run for an entire hour, I had no idea if I'd even produced anything at all. So I decided that I had to check on it by getting rid of the liquid nitrogen and by letting all of the frozen stuff melt, and at first, it was looking really promising. However, as it slowly disappeared, it eventually became clear that things were in fact not looking promising, and once it had all melted, I was honestly kind of devastated. This was because all that was left was barely a milliliter of liquid, and apparently, even with all of the extra hydrogen and with the more activated catalyst, it was somehow even worse than my first attempt. But despite that, for some reason, I still had faith that the catalyst would eventually work. I also really just felt that it needed some more time to get going, so I decided to put the liquid nitrogen back and to let it run for another hour. Then, when I started thawing it out again, I was really hoping to see that some sort of miracle had happened and that the catalyst had just magically worked this time, and well, that was kind of exactly what I saw. More specifically, unlike before, there was a whole bunch of stuff in the middle that didn't just look like it was dry ice, and most importantly, as I kept warming it up, it didn't seem like it was just vanishing. In fact, it was eventually clear that it was starting to melt, which told me that for sure, it wasn't just dry ice. What was also really exciting was that, unlike last time, it kind of looked oily, or at least it didn't look like it was pure water, and when it all eventually melted, I actually had a surprising amount. Then, when I started pulling it all out with a pipette, I genuinely couldn't believe just how much liquid there was, especially considering that the previous hour had basically produced nothing. On top of that, what I thought was really interesting was that when I smelled it, it was very different than all of the other times, and it was not at all what I was expecting.
Huh. Smells like banana or something. It smells fruity.
But either way, after this little bit of surprise success, I decided that I might as well just keep running the system and to use up the last bit of CO2 that I had. So that was exactly what I did, except this time I decided to push the system to the limit of what it could handle by increasing the gas flow over the catalyst to the absolute max. This was mostly because it was getting late and I wanted to go as fast as possible, and for the most part, this should have been fine. I mean, I did know that this was going to put a lot of strain on my air compressor, which was not really rated to run the gas booster constantly.
It's gonna explode.
And I wasn't too surprised when that was exactly what happened. But at the same time, I also didn't really care that it happened, because just by chance, I had basically used up all of the CO2 that was left, and at this point, I felt it was a good time to end things.
I think that's it.
So, just like every other run, I then got rid of the liquid nitrogen, and as it slowly warmed up, I was assuming that at best, I would get something similar to the last run. However, that apparently wasn't the case, and somehow it looked like there was even more, and after heating it for a few minutes, I was honestly shocked by how much there seemed to be. Then, once it all eventually melted, I quickly pulled it out and I transferred it to another vial, and again, I was kind of shocked when I was almost able to fill the entire thing.
This is like double or triple what I got from the last one. How? How is it so much more than the other one?
So apparently, properly reactivating the catalyst did in fact do something, and there seemed to be some sort of trend going on where every time I ran it, it seemed to work better.
Interesting.
Either way, though, at this point, with literally no CO2 left, I was officially done using my whole setup, and what I had to do next was purify all of the air alcohol that I had made. This was especially because what I had now was still full of nasty side products and things like methanol, which I would definitely have to get rid of before I could even think about tasting it. So that's what I quickly did next by first getting a separatory funnel and by dumping in everything that I had. Then after that, I drained out the lower water layer, which should have contained pretty much all of my ethanol, and I left behind all of the banana smelling oily stuff that was floating on top. I should also say that I didn't know exactly what this stuff was, but it was probably just a mixture of random hydrocarbons and other side product crap. But anyway, after just that, what I had was already a bit cleaner, except it was still really dirty, and I was of course gonna have to do a lot better. So what I did next was quickly put together the smallest distillation setup that I could, because I wanted to lose as little ethanol as possible, and when I felt that I was ready, I turned on the stirring and heating. I then patiently waited for the temperature to rise, and I ended up tossing out everything that came over before 80°C, which should have been mostly methanol and other junk. Once it got a bit over 80°C though, ethanol should have been starting to come over, so I quickly swapped out the vial for a fresh one. I then continued collecting it, and during this time, the temperature slowly rose as more and more water came over with the ethanol, and when it eventually got all the way up to 95°C, I pulled away the vial. Then after that, I added a stir bar to it, as well as some activated charcoal to clean it up as much as possible, and after leaving it like this for about an hour, I filtered it through some cotton. This allowed me to get rid of all of the charcoal, and when it all eventually passed through, I was feeling pretty good, because what I had now was completely clear and colorless, and it was as pure as it was gonna get. What was also really exciting was that when I put a few drops of it onto my alcohol refractometer and I looked inside, it told me that what I had was around 8% alcohol, which was honestly way better than I was expecting. I mean, it wasn't the super concentrated vodka that I was hoping to make when I started this project, and I guess what I made was more like a strong beer, but I was still really happy with it. The only concerning part was that when I did the final NMR, I saw that unfortunately, even after the distillation, it still had this little peak here that was not coming from ethanol. Instead, it was coming from a small amount of methanol, which is of course quite toxic, and what was really sad was that getting rid of it was going to be basically impossible. On top of that, with the methanol present, it did technically mean that the reading on my refractometer was a bit artificially high, and after doing a bunch of tests and calculations, I found that the true ethanol percent was likely around 7. Overall, though, I didn't really think that this was a huge deal, and with my air alcohol now finally in hand, I was much more focused on something else, which was answering the very important question that had been on my mind for years.
What does air alcohol taste like? Is it good? Is it bad? I guess we'll find out.
Except as I just mentioned, it did contain methanol, which is both toxic and extremely dangerous to ingest, and this was why I was only going to be tasting a very small amount. This way, there would be so little methanol that it would be totally safe, even if the entire amount that I was tasting was just pure methanol. However, I should say that technically this was still all at my own risk, and I don't recommend anyone trying anything like this.
But with that being said, I guess I just have to go ahead and try it. So, let's see. It definitely tastes like alcohol, and it's definitely stronger than, a typical beer or something, but overall,
It's actually pretty good. I mean, I personally am not the biggest fan of alcohol in general, so I'm probably, honestly, a terrible person to review this. But it's not bad. It has a very clean taste. There's basically no real aftertaste or weird taste to it. I'd say it's pretty close to if I just put pure ethanol in water. But it does have a unique flavor. It does have something unique going on. And I think this is a really good result. I really need to scale this up. I need to figure out a way to actually make this scalable and to make a full bottle of this without the methanol. That would be really, really interesting.
So, with that being said, that's exactly what I plan to do next for Air Alcohol 2.0, and at the same time, I'll do my best to fix a bunch of issues with the current process. Like the fact that right now, my method of getting CO2 is an absolutely massive bottleneck, and it's both really inefficient and painfully slow to get even small amounts. Or like how in the setup, I have the gas flowing from the bottom of the reactor to the top, which I think is forcing the water and ethanol vapor to fight gravity and to get trapped inside, and to mess things up. On top of that, I will very likely end up swapping out the catalyst for a much simpler one, which will probably be a lot less efficient, but I think I can counter that by just making a massive amount of it and by recycling the CO2.
Either way, though, I think that's about all I have to say about making air alcohol. But before I go, I feel like this is a good time to mention some of the other air related projects that I'm working on, like turning air into gasoline, air into a bomb, and air into diamond. On top of that, I should say that I'm getting pretty close to finishing some of the projects that I started years ago, like making magnets from scratch, spinnable carbon nanotubes, and liquid helium. Also, I think it goes without saying that all of these projects are both extremely time consuming and expensive, and this is why I'm very thankful for all of our amazing YouTube members and patrons, and for our sponsors like Odoo, who make long projects like this possible. If you haven't already heard of Odoo, it's basically an all-in-one platform that provides everything you need to run a business, and they have a ton of intuitive apps for things like managing sales and tracking inventory. They also have a custom website builder, which is personally my favorite, and I actually use it all the time to make random websites for some of the projects that I work on. I even went ahead and made one for the air alcohol, which I was easily able to do in barely 20 minutes, and I think it turned out pretty well. Besides just making websites though, something else that I really like about Odoo is that it can easily scale based on your needs, and you don't have to immediately commit to a bunch of apps. In fact, you can actually just start with one app and then scale from there at your own pace, only adding more when you need them, or even removing them if you stop needing them. All of this is also all available in just one simple interface with just one subscription, which I think is way better than having to subscribe to a bunch of different services. But with that being said, I personally really like Odoo, and whether you're looking to just build a website or whether you're looking for an all-in-one solution for your business, I definitely recommend checking them out. Right now, you can also try everything that Odoo has to offer for free for 15 days with no credit card required, and you can get one app completely for free for life by simply going to the URL on screen or by clicking on the link in the description. But yeah, I think that's about all I have to say. We've officially made it to the end of the longest video that I've ever made. And I guess I'll see you on the next one.
As usual, a big thanks goes out to all of my supporters on YouTube and Patreon. Everyone who supports me can see all of my new videos at least 24 hours before I post them to YouTube. You'll also get access to all the older videos that I had to take down, and if you support me with $5 or more, you'll get your name at the end like you see here.